This conference will now be recorded.
So today let us move to the next topic, Java 8 version features. In Java 8, we are having the features got added like define methods in interfaces. We can define what? Methods in interfaces using default keyword. Define static methods. Define static methods in interfaces. This already we have discussed. Adding some more like Lambda expressions, functional interfaces for each method, method reference, and stream API. So we are going to discuss this remaining part today. Now let us initially go with this Lambda expressions. So the main use of doing with Lambda expressions is the expression through which we can represent an anonymous method. The expression through which we can represent what? An anonymous method. What is anonymous method is? Anonymous method which does not have any name. No name to the method only we call anonymous method. And the syntax of going with Lambda expression is we just go with the parameter, then we go with the expression symbol, then body means the code of your method. So what is parameter? Like this. So when you take a method, if you take a method 1, so no need to mention the method name. That's the main thing of Lambda expression, which it's mainly to represent anonymous method. So here we won't go with any method name, and the expression symbol for Lambda expression is RS symbol, hyphen greater than, and here we go with the content of your method. With the content. The next feature is functional interfaces. Functional interface. What is this functional interface? Is the interface which contains only one abstract method. The interface should contain what? Only one abstract method, but can have multiple default and static methods. So an interface we can have multiple default and static methods. Then is called as functional interface. Called as what? Functional interface. At the rate functional interface, annotation is used to mark the interface as functional interface. Whenever you want to mark an interface as functional interface, we have to use which annotation? At the rate functional interface. And some of the predefined functional interfaces are like runnable interface. So which contains only one abstract method, run. Comparator interface which contains only one abstract method, compare. And one more like comparable interface. Comparable interface contains only one abstract method, compare to, like this. These are some of the predefined functional interfaces. Now let us understand these two topics. Let us understand what is this Lambda expression in functional interface with an example code. Lambda demo. Open Eclipse. To store Java related programs, Java 8 related programs, let me create a new package, Java 8. I click on Java 8 package and it's a new class, Lambda demo with main method. Now, in this, let us create one interface. I'm creating one interface phone with a method call. Since this interface contains only one abstract method, we can mark it as functional interface. How to mark it as functional interface? At the rate functional interface. Right? Now, once you mark it as functional interface, if I try to add one more abstract method, then see it's going with error. It's going with what? Error. Because once you mark it as functional interface, it should contain only one abstract method. Right? Now, once we create interface, what we do? We create a class which implements interface. Let us create a class Android phone which implements phone. Then once this class implements phone, we have to override the method. So keep mouse pointer on this error and say add an implemented method. So we are overriding the method here. And you can go with the message, some message, the implementation of call method. So we'll simply say calling. Coming to the main method, what we do? We create reference of phone, referring to this Android phone. Then by using this reference, we can invoke the call method. Right? Now see when we run, we're getting the message calling. Right? So this is the way how we use it to work up to now. There. So why we are creating this subclass? Only to override the call method. Understand carefully why we are creating this subclass? Only to override the call method. So instead of creating a subclass only to override the call method, we can make use of one more concept. We can make use of a concept called as anonymous inner classes. Anonymous inner class. This is present from beginning of Java. How to go with this anonymous inner classes? Just to select this phone p equal to new phone p equal to new phone, and in between this open and curly braces, we have to override the call method. Override the call method. I'm going with the message calling. That's it. Okay. So here we are writing a method, but there is no name to the class. We can write methods inside a class. There is no name to the class. That's the reason we call it as anonymous inner class. Now by using this p reference, we can invoke call method. Now same, we get the message calling. Now this is present from beginning of Java. Then we are having one more concept like Lambda expressions. Using Lambda expressions. This is important. Using Lambda expressions. How to go with Lambda expression is simple. See, just to copy the code whatever you are having in anonymous inner class. Just to copy the code as it is, what you are having in anonymous inner class. Then what Lambda expression says to represent anonymous method. What is anonymous method? No name to the method. So what you do? Just you remove the code up to the method name. Just you remove the code up to the method name. So simple parenthesis. Then what you do? Go with the arrow symbol, Lambda expression symbol. Then write the code inside the method. That's it. Write the code inside the method. This is the way to write the Lambda expression. Just to take the code as it is from anonymous inner class, just remove the code up to the method name, and this is the content of your method. This is the body of your method, and this is the symbol what we use for Lambda expression. So what is the meaning here? What is the main thing of Lambda expression? Already we know what is the method name to override, because in functional interface we can have only one method. So already we know what is the method name to override. Why to mention the method name once again here? That's the main thing of Lambda expression. No need to mention once again. That's the main concept of Lambda expression. Clear all of you? How to go with the Lambda expression? Right? So we are having other syntaxes also. Let me discuss that. We are having only one statement. We are having only one statement under this method. Then using curly brace is also optional. Using curly brace also optional. Then if the method is taking an argument, the number which you want to call, if the method is taking an argument, then how to manage the code with argument? How to manage here? We have to pass the argument here, the number, and say calling, pass the number which you want to call. You can even go with the arguments. So if the method is taking argument, here you can pass even the argument. Then already we know what is the data type of argument. Then why to mention the data type once again? We can even remove the data type also. Because already in the method we have mentioned what is the data type of argument, then we need not mention the data type here. Pairing one more, like if there is only one argument in the method, if there is only one argument, then providing parenthesis is also optional. So the main thing of Lambda expression is reducing burden to the developers. Whatever you have already mentioned, you need not mention once again. That's the main thing of going with Lambda expression. Got it? Clear? Any questions? You need to practice it compulsory. No. The next important feature is Stream API. What is this Stream API? Is Java Stream API is used to operate on the source data structure. Data structure means collection of data. Either you can collect the data using arrays or collections. Mainly to operate your data structure like arrays or collections, where we collect the data. Once you collect the data, we want to operate the data. That operating things we do by using Stream API to operate on the source data structure and provide pipelined data that we can use and perform specific operations such as we can create a stream from the list and filter it based on the given condition. So whatever collection we are having, we can even operate the data present in your collection. We can even do that before Java 8. From Java 8, we are using Stream API to operate the data present in your collection. Why? Because the main use of going with Stream API is using Stream API, the performance of the application is increased. When we use Stream API, we can increase the performance of the application. Stream API is present in java.util.stream package. Stream API is present in which package? java.util.stream package. Now, let us understand more with the program. Stream demo 1.java. In this program, we will be just learning about how to create a stream, how to create the stream that we are going to learn in this application. In the next example, we'll see how to process the data, how to operate the data, that is filtering based on the given condition. That we'll see in the next example. So this example mainly to convert your array or collection into string. Right click on Java 8 package and it's a new class, stream demo1 with main method. Now import the packages, java.util package, java.util.stream package. Before we proceed, how to create a stream, first of all, let us understand the different ways of traversing a collection. This is very important interview question. What are the different ways of traversing a collection? Now, for this, let me create a list of string list1 equal to list.of. I said no in the last class, we are having collection factor method of. To this, we can pass the list of elements. So I'm adding some list of elements here. To this list, we are adding some elements. Now I want to traverse this list. So when you print list1, how we get the result? It's going to show the elements within square bracket separated by comma, right? This is how we get the result when you print the list1 object. Now what I want to do, I want to pull out one element and use it. Then how to, that only we call traversing or iterating. How to do? Using traditional. This is present from beginning of Java. How to use for what type of elements the list is holding? String, right? But here we go with index based. Traditional for loop means index based. So I equal to 0, I less than list1 dot size, which is going to give the number of elements, then I plus plus. And when you are printing, we'll say list1 dot get of I. So based on index, using get method, we are pulling out one element from your list and displaying. This is by using traditional for loop. Okay. Using enhanced for loop. Using enhanced for loop, this is added in Java 5 version. How to use enhanced for loop? Here we have to say for what type of elements the list is holding? String. So you can say string, some variable name colon list1. That's it. It's going to pull out one element from list1, stores into s variable, just to print the value of s. So this also is going to traverse your elements. The next one, using for each method, added in Java 8 version. Added in Java 8. How to use is just to add say like this. List1 dot for each. List1 dot for each. Take some variable name, then apply the lambda expression symbol and say system dot out dot println the value of s. So what you are doing? In the previous case, we are mentioning data type to store the value into this. So compulsory we have to mention the data type. In the case of for each, why to mention the data type of this variable? Already we know what is the data type of this list. So what it is going to do? It's going to pull out one element from list1, stores that value into s, and what you want to do, just you want to print on the screen here. So taking the value of s and we are printing the value onto the screen. So the lines are getting reduced over here when we apply this lambda expression. Next one, using method reference, added in Java 8 version. When you know what are the values present in list1, I want to just print it onto the console screen. I want to just print on the console screen. So what you are doing in this case, you are taking the value of list1, storing into a variable and printing it. So instead of storing into variable and print, I want to directly print the values present in list1 onto the screen. So how to do this one? Just to say like this, list1 dot for each, just simply say system dot out to colon println. Whenever you see 2 colon, they are called as method reference. So it's going to take the value from list 1 and directly it's going to print on screen. So that only we call method reference. So these are the different ways of traversing your collection. Clear all of you, the different ways of traversing? Right? Now let us see how to create a string. Creating a string using list. So for this, we have to just use the interface string string string1 equal to, just to say like this, list1 dot string. Just we have to call which method? This is our list1. If I want to convert this list into stream, once you convert into stream, we can operate the data present in your collection. For that only we convert into stream. How to do? Simply use which method? Stream method. That's it. It's going to convert our list into string. Now, print the values present in stream1. Stream1 dot for each system dot out to colon println. So when we run, it's going to display the values present in stream1. Creating a stream using set. So let us create a set here. Set string set1 equal to new asset. To this asset, you pass your list1 as argument. Whatever the list1 we are having, this list1 you are passing an argument to asset, then this list will be converted into set now. So if the list contains duplicates, that also will get removed here. Now I want to convert this set1 into stream. Simply can say stream stream2 equal to set1 dot same method stream. Simply we use stream method to convert our collection into stream. Print the values present in stream2 dot for each system dot out to colon println. So when we run, we get the values present in set here. Next one, creating a stream using arrays. Let us take an array. We are creating an array with some values. We are having an array. I want to convert this array into stream. Then you can say stream3 equal to arrays dot stream. In arrays, we are having a arrays class present in util package with a method stream. To this, we need to pass our str array. That's it. This is the way to convert our array into stream. Let print the values present in stream3. So when we run, we get the values present in stream3. So these are the different ways of creating stream. Clear all of you? Any questions? Now let us go with the major topic. This is the major one. Filtering using stream API. Whatever the data present in your stream, I want to filter. I want to apply the filtering concept. For this, we use the method filter method. Filter method is an intermediate operation. Filter method is an intermediate operation that reads the data from a stream and returns a new stream after transforming the data based on the given condition. We want to create a new string based on the given condition. Let us understand with the program. in demo 2. It's a lengthy code here. Right click on package and it's a new class. In demo 2. In this, import the packages. Here we are creating a class product. I'm creating a class what? Product. With the data members, product ID, product name, and price. Now go with a constructor, right click and say source, and you can see the option C, generate constructor using fields, generate. That's it. It is going to create a constructor for you. If a class contains parameterized constructor, it is always suggested to create a default constructor. Your class is ready now. Coming to street demo 2, in this class, let us create one private method, private static, list product, get products. I'm creating what method here? Get products. Now, whenever you call the method get product, it should return the list of products. So, first of all, let us create a list product list equal to new array list or linked list. Now, to this product list, let us add the products. So, you can select this product list dot add new product. So, to this add method, we are adding the product objects. So, to the product list, we are going to add product objects. So, to the constructor, you pass the product ID, product name, and price. Like that, let us add some more products. So, what you are doing, just we are creating a product list. To this product list, we are going to add some products. Just we are adding the product objects. We have added some products into the product list, then say finally return product list. Whenever you call the method get products, it's going to return the product list. This product list contains these 5 products. Now, coming to main method, here if I take for product colon get products. Whenever you call the method get products, it's going to return the product list. So this all product list is written over here. Now we are traversing our product list. One product will be stored into product. Just print it. Just print the product. Now see the output. It's returning class name along with hash code, because whenever you print an object in SOP, it's going to invoke which method? ToString method. So in your class, override the ToString method. Already we discussed on all these things. Where we return product ID space product name space price. Whenever we print objects in SOP, remember it's going to invoke which method? ToString method, where we are returning product ID, product name, and price. Now we are getting the result here. So what we have done just in this example, we have just created a class product with the product ID, product name, and price. Using constructor, we are giving the value to data members. Then we are creating a get products method, where we have added the products into this product list and we are returning product list. And here we are traversing our product list. We have done only that part. Now let us understand filtering. Now I want to create a list. Now we are creating a list, list 1. equal to new array list. Now to this list 1, in this list 1, I want to store only the products whose price is greater than 1000. So whose price is greater than 1000 means we get this monitor and UPS. These two products I want to store it into list 1. So that only we call filtering. So to apply that filtering, you can say first of all get the products, take one product into product. Now check here. If product dot price greater than 1000, I'm applying condition, taking one product and checking whether the price is greater than 1000. If the price is greater than 1000, add this product into list 1. List 1 dot add your product. That's it. So what you are doing, you are taking one product and checking whether the price is greater than 1000. If it is greater than 1000, I'm adding that product into list 1. Now see, if you print here, list 1 dot for each system dot out to colon println. Now see, the values present in list 1, it's going to display only the products whose price is greater than 1000. So this concept only we call filtering. And how we are doing filtering? Using traditional approach only. Without using streams only, we are using filtering. So we can even, without using streams also, we can able to do filtering process. But here only 5 products, no issue. But in reality, you may go with hundreds of products, thousands of products. Then at that time, performance will get degraded. When I write the code in this format, performance will get degraded. That is a place where we go for stream API. That is a place where we go for stream API. How to go with stream API is just write like this: list product list 2 equal to get products. First of all, get the products. When you call the method get products, it's going to return the list of products. So this is our list of product. Convert this list into stream. How to convert this list into stream? Using stream method. Once you convert the list into stream, now I want to apply the filtering. So which method we have to call to filter? Filter method. To this filter method, take one product, and check whether the price is greater than 1000. Only we are applying condition. So I'm converting into stream. I want to filter your stream, so call the method filter. Take one product, check whether the price is greater than 1000. So then, if it is greater than 1000, then collect that product. Once you collect that product, I want to convert into list. Then we have to use a class collected dot to list. Single line of code is doing the task to you. So I'm repeating. We are getting the products, converting that products into stream, the list into stream. Then we are applying the filter method. Take one product and check whether the price is greater than 1000. If the condition is true, I'm going to collect that product. And since I want to assign to list, we have to call the method collectors.toList. That's it. Now if you print your list 2, it contains only the products which contains whose price is greater than 1000. Using stream API also, we are getting the same result. But the thing is, when you go with stream API, performance of your application is increased. So ordinary traditional approach, performance is low if you are having more number of products. Then when I go with stream API, performance of your application can be increased here. Got it, all of you? Any questions? Right? So that's about this streams concept. Now, as I mentioned yesterday, I'll be taking one application where you will be knowing the importance of going with object-oriented approach, that is polymorphic feature. What is the need of writing like this? So we can even say array list 1 equal to new array list. So why we are writing list equal to new array list? What is the advantage of following this approach? Like we have seen vehicle equal to new car. So why we have to follow that procedure? So that we call polymorphic approach. So that only I am going to discuss with an example. Here for this, let me consider we are having an inventory. We are having a class inventory which contains some collection of nuts, bolts and screws. Contains what? Some collection of nuts, bolts and screws. Let us suppose in our inventory, I am just going with small values, 3 nuts, 2 bolts and 1 screw. And let us suppose the cost of each nut is 10, then the total cost of nuts is 30. The cost of each bolt is 20, then the total cost of bolts is 40. The cost of each screw is 30, the total cost is 30. Now, in this inventory, let us go with a method, total cost, which returns the total cost of all the items. So, what is the total cost of all the items here? 100. So, 30 plus 40, 70, 70 plus 30, 100. So, in this, we are going with a method total cost, which returns the total cost of all the items present in the inventory. So, this type of diagrams, we call them as class diagrams. We call them as what? Class diagram. And in this, the first box is your class name. The first box we call it as class name. Second box is your data members, and third box is your methods. This is how the class diagram looks. So in reality, when you are working in projects, they'll give the class diagrams. Based on the class diagram, we convert that diagram into code here. Okay. Now let us write this code. So let us write this code initially without using any polymorphic approach. Let us write the code. So for this, we are going with the program inventory demo1.java. I'm going with what? Inventory demo1.java. See. Right click on package and say new class inventory demo1 main method. In this, import your util package. Now here we are creating a class nut, because to the inventory we need to add nut, bolt and screw. So what we have to do, we have to create a class nut with a data member nut cost. In the constructor, we are providing the nut cost as state. I'm just going with hard coded to make our calculation simple. So whenever you create object of nut in the main method, whenever you create object of nut, what is the value of nut cost will be 10. Remember that. Now let us create a method nut cost. Whenever you call the method nut cost, it's going to return the value of your nut cost. Okay, so here I can apply the encapsulation. If I say private, then only by using this method nut cost, I can able to get the nut cost. Directly we cannot get the nut cost value. Okay. Then similar way, create a class bolt with bolt cost. bolt cost. In the constructor bolt, we'll give the bolt cost as 20. Let us create a method bolt cost. Whenever you call the method bolt cost, then only it's going to return the value of your bolt cost. Returns the value of bolt cost. Similarly, let us create a class screw, which goes with a data member screw cost. In the constructor screw, we give the screw cost as. Then we create a method screw cost. Whenever you call the method screw cost, return the value of screw cost. Right? So just we have created 3 classes, nut, bolt, and screw with the values. Now let us come to the major code. Let us create a class inventory. In inventory, what we are going to add? Your nuts, bolts, and screws. So here we create array list of nuts equal to new array list of. Let us go with array list of bolts equal to new array list of bolt. Then array list to screws equal to new array list of screw. We are creating 3 array lists, nuts, bolts, and screws. Now let us add this nuts, bolts, and screws to the inventory. For that, let us go with the method void add nut. To this add nut method, we pass nut object as an argument. Then to this nuts, we are adding the nut object. Whenever you call the method add nut, to that if you pass your nut object, the object whatever you are passing, we are adding it to this nuts array list. See here in the main method, let me create 3 nuts. Nut entry equal to new nut entry equal to new nut. So we are creating 3 nut objects. Now I want to add these 3 nut objects into this nut. So which method I should call? I have to create object of inventory equal to new inventory. So using this object inventory I, we can call the method add nut and pass your n1 I dot add nut into I dot add nut n3. What you are doing? We are creating 3 nut objects, and how to add these nut objects into inventory? By calling this add nut method. So to this add nut method, we are passing your nut objects as argument, taking that objects and adding into this nuts array list. Similar way, let us go with add bolt object. You will say bolts dot add. In the main method, create bolt objects. Bolt b1 equal to new bolt b2 equal to new bolt. We are creating 2 bolt objects. Then add these bolts to the inventory. I dot add bolt b1, I dot add bolt b2. So to this inventory, we are adding 2 bolts. Similarly, create a method add screw, which takes screw as an argument. Then we'll say screws dot add s. In the main method, create one screw object. And say I dot add screw. This one. That's it. So to this inventory, how many nuts we have added? 3 nuts, 2 bolts, and 1 screw. Okay. Now go with our actual business method. What is that? Total cost. Whenever we invoke the total cost method of inventory class, we should return the total cost of all the items. So to do, take a variable total, whose initial value is 0. Now say for nut n colon nuts. This for loop will repeat for how many times in our example? How many nuts we are having? 3 nuts, right? N1, N2 and N3. So this for loop will repeat for how many times? 3 times. Now take the nut cost. Say your total equal to total plus n dot nut cost. So whenever we invoke this n dot nut cost, goes to this nut cost, and it's going to return the nut cost. What is that? 10 here. So after this for loop, what is the value of total? 30, right? So because this for loop will repeat for 3 times, because we are having 3 nuts. So after this for loop, what is the value of total? 30. Then now find the bolt cost for bolt b colon bolts. How many bolts we are having? In this example, 2 bolts. B1, B2. Now say total equal to total plus B dot bolt cost. So what is the bolt cost? 20. So this for loop will repeat for how many times? 2 times. So already the value of total is 30. So 20 plus 20, 40. 40 plus 30, 70. So after this for loop, the value of total is 70. Similar way for screw, S colon screws. How many screws we are having? Only one, S1. Then say total equal to total plus S dot screw cost. What is the screw cost here? 30. So this loop will repeat for one time only because we are having only one screw. So 70 plus 30, 100. So after this for loop, what's the value of total? 100. Now see, in the main method, if you call the method total cost, by using object of inventory, if you call the method total cost, what is the value of total cost we get here? See, 100. 100 here. Clear this program up to here? Just to try to understand, that's enough. Now here we did not apply any concept of inheritance and polymorphism. So just we have written the code. Now let us see the drawbacks of this code. The drawbacks are like in future if I add a new item nail, in future if I add a new item nail, so let us suppose we are having 4 nails, the cost is 25. It is 100, right? So the total cost will become now 200. So if I add one more new item nail, then do we need to modify this piece of code? In future? So once we write the code and submit to the client, from that time we call maintenance phase. So during maintenance time, the client is adding new requirements. So new item is added. So when the new item is added, again we have to create a class nail, and in the inventory class we have to create one array list of nail, add nail method, and again we have to modify the total cost method. Means whenever the client is adding new items, every time we have to come back to this inventory class and modify our code. Do you agree with this point? Yes, Sindhu, do you agree with this point?
Yes, Raj.
That's right. So whenever we add new item, do we need to come back to inventory class and modify the code?
Yeah.
That's right. That is the drawback with this code. So again, if I modify the code, again, do I need to send this class for testing again?
Yeah.
Yes, right. So means whenever we update the code, every time I'm sending this class for testing again and again. So the testing phase time is getting increased again. So means maintenance cost is increasing over here with this approach. Now let us write the same code using polymorphic approach. See here how to do. I'm just copying the same piece of code. Now under my pack 1, I'm creating the new class inventory demo 2. Paste this piece of code. Enter my pack 1, paste the piece of code and go with the class name demo 2. Inventory demo 2. Okay. So in this one, understand carefully. This nut, bolts and screws. For this, can you go with some common name? Like if I say apple, mango, orange. What is the common name? What they are? Fruits. If I say table, chair, table, chair are like furniture. So what is the common name I can say here? I can say item. These are what here? Items. To the inventory, I'm going to add some items, whatever the item it may be. So this is the common name. Okay. So think in the terms of hierarchy first. Think in the terms of hierarchy. So what do? You create a class. You create a class item. To create a class item. Now understand carefully. Whenever you want to get the net cost, we are using a method net cost. Whenever you want to get the bolt cost, we are using the method bolt cost. I want to go with commonality. Means whenever you want to get the cost of an item, I want to go with a common method cost. So here I'm going with a method cost. Now I want to ensure that your item, if it is an item, nut is an item, bolt is an item, screw is an item. So whenever you want to ensure this cost method need to be overridden in your item subclasses, then how to ensure? By going with what? Abstract class. We create one abstract class item and make it as an abstract method. When you make it as an abstract method, then if any class extends our item class, they have to compulsory override cost method. So if net extends item, see, immediately we get error and we have to override which method? Cost. So I cannot go with our own methods. So we have to override this cost method. That's the need of going with abstract classes or interfaces. So ensuring that your subclasses should override some method names. So making commonality, then we go with this cost method. So this only we call polymorphic approach. Okay. Then similarly, bolt extends item, then we have to override the common method cost. Similarly, screw extends item, here we have to go with a common method cost. Coming to inventory. To the inventory, what you are going to add? Items. I'm not worried about whether it is nut or bolt or screw. I'm going to add what here? Item. I'm going to add here items. These two are not required now. So what I should add to the inventory? I'm not worried about whether I'm adding nut or bolt or screw. I'm going to add what? Item. Add item, which takes item as an argument. Then we'll say items dot add items dot add I. See here in the main method, we create object of inventory. Now here we are not going to create nut, bolt and screw. We have to create item. So I'll say item n1 equal to new nut. So n1 is referring to what now? Nut, because finally I should add item. But internally what I am adding? Nut here. I'm adding nut object. But when you are creating objects, how to create now? Item n1 equal to new nut. So base is referring to subclass, because the argument is of type item here. So I'm applying polymorphic approach. Any type of item I should able to add. So I have to say item n1 equal to new nut. So because the argument is of type item here. So here also item n2 equal to new nut. Item n3 equal to new nut. Base is referring to subclasses. Now here we have to say add item now. Add item. Add item. Add item. So we have added totally 3 nuts, but they are referring to item here. Similarly, item B1 equal to new bolt, item B2 equal to new bolt. Add item B1, add item B2. Item S1 equal to new screw, add item S1. So we are just calling a common method add item. So to this, how many arguments you are passing? N1, N2, N3, and B1, B2, and S1. N1, N2, N3 are referring to which object? Nut object. B1, B2 are referring to bolt object, S1 is referring to screw object. So just we use common method add item to add all the items of the inventory. Now these two methods are required now? Not required. Coming to total cost, we take a variable total equal to 0. Here we say item I equal to items. How many items we are having totally? 6 items. So this loop will repeat for how many times? 6 times. Now here we have to say I dot cost now. I dot cost, because the common method is what here? Cost here. So we have to simply say I dot cost. Understand carefully. These loops are not required now. So first, which item it is going to take? N1. N1 will come and store into I. When I say I dot cost, since this N1 is referring to which object? Not object. So when N1 is referring to not object, when you call cost method, it will go to which cost method? Not cost method. Whichever the object you refer, it will go to the respective method and it's going to return net cost, which is 10. So for N1, N2, N3, it's going to invoke cost method of net. For B1, B2, it's going to invoke cost method of bolt. For S1, it's going to invoke cost method of screw. So which cost method it's going to invoke? That is not decided during compile time, that is decided during runtime. That's the reason we call runtime polymorphism. This one we call runtime polymorphism. Right? Now see, when we run, we get the same output. Total cost as same 100. Now see, in future, if I add one more new item, in future if I add new item nail, do I need to modify this piece of code now? Nothing. Just to create the class and test it for some items. Just to create the class and test it for some items. See here, what you are doing in the total cost, we are taking only one for loop to find the total of all the items. In future, if I add one more item like nail or anything, do I need to modify this piece of code now? Do I need to modify this inventory class now? Not required at all. Whatever the item it may be, my class is ready to face. Okay, so this approach only we call polymorphic approach, and the suggested way of coding is like this. Always base should refer to subclasses. This is always suggested piece of code, so that whatever the type of argument it may be, I should be able to manage here. Right? Okay, so no need to remember this code, just understand the approach how we follow in reality. Base should refer to subclasses. Right? Clear, Sindhu? Right? So please practice this whenever you get some time. Right? Then tomorrow we go with one more new topic, IO package. Very, very simple topic tomorrow, IO package. Then next class SQL concepts using MySQL. Then one more class JDBC. So 3 more classes left out for us to complete our core Java. Thank you all. Thank you very much.